In this lecture, we'll discuss the concept of observability and constructibility for linear systems. So consider the system which is of this form. Now we had seen the state feedback controller for LTI systems. Even for linear time varying systems, at some point of time we might need to design state feedback controller. So essentially the states have to be fed back as input to the system so as to close the loop. Now, these states might not be available as it is in the form of the output, or probably these states cannot be measured and hence they cannot be directly used in the feedback. Hence, we need to guess or estimate these states. Okay, and these can be constructed or reconstructed rather from the input ut and the output yt. Now, if you observe the output equation, if ct is invertible for all time and the number of states that you have is exactly equal to the number of outputs that you have, then you can instantly reconstruct the state vector x from the output y and the input u, okay, as shown here. But this may not be a general case where the number of inputs is exactly equal to the number of states and C is going to be an invertible matrix over all time t. So we have to find a way through which we can actually guess what the states are going to be from the input and the output. Okay. And we should be at least able to reconstruct or guess the states xt, okay, from the input and the output over a time interval t0 till t1, over a time interval t0 till t1. Okay, so there are two concepts that come up. One is observability and one is constructibility. Observability is essentially determination of what the state was at the beginning of the time interval, okay, from the output and the input for any time t given in the time interval t0 to t1. Okay, so at any instant of time in the interval t0 till t1, we should be able to tell what x of t0 was. Constructibility, on the other hand, is determination of what the states are going to be at time t equal to t1 given the input and output in the time interval of t0 to t1. Okay, so meaning at some time, if you know the input and the output y, input u and the output y, then can we reconstruct the state vector x that we'll have at time t equal to t1? Okay, that is what is constructibility. Okay, so one is concerned about reconstructing the state at the beginning of the interval, one is concerned about reconstructing the state at the end of the time interval. Okay, so we'll first see what observability is. Constructibility will be similar to what observability is going to be. Okay, so in observability, as I said, we want to know what x of t0 is. Okay, so let's say that x of t0 is nothing but x0. So the output y of t can be essentially expressed in the shown form. Okay, now to find x0, we need to solve this equation because the only unknown here is x0. You know your state transition matrix, you know your C, you know your B, you know your input, you know your D. Everything is known except for x0. So x0 is the unknown. we need to solve this equation so as to find what x0 is. This is equivalent to solving the following equation: y tilde is equal to c phi x0. Okay, or y tilde is nothing but the difference between y and the other terms in the above equation where x0 is not present. Okay, so if we solve y tilde equal to, if we are able to solve y tilde equal to ct phi a t t0 x0, then we will come to know what x0 is. Okay, now if it so turns out that y tilde is 0 while x0 is not necessarily a 0 vector, then essentially what it means that the output y does not have any information about x0. Okay, so this brings us to the definition of a unobservable subspace. Okay, what is basically happening here is, if if y tilde is 0 while x of 0 is not 0, then y, as I said, y, the output y will not have any information of x0. Now since output y has no information of x0, that means you cannot reconstruct x0 from the output that you have in hand. Okay, so what is an unobservable subspace? So given a time interval t0 till t1, the unobservable subspace on this time interval t0 till t1 is essentially all those x0s for which c phi x0 is going to be 0 for all time in the time interval t0 till t1. Okay, so for all, any time instant that you take, what for every time instant that you take in the interval t0 till t1, the c phi x0 will always be 0, which means all those x0s whose, because whose information is essentially not present in the output. Okay, now if it so happens that the unobservable subspace is such that the 0 vector is the only element in this unobservable subspace, then the system is said to be observable over the time interval t0 t1, which means essentially that there is no non-zero x0 for which y tilde will be 0. So y of t will have the information of x0 embedded in it, which can be extracted. Okay, so if the unobservable subspace has only the 0 element, then the system is said to be observable over the given time interval t0 till t1. Okay, now notice one thing, that in the determination of the unobservable subspace and hence observability of the system, the matrices B and D do not play any role. Okay, so B and D are not playing any role in determination of observability of the system. It's the matrix A and C which are actually needed to determine the observability of the system, because the state transition matrix depends on A, and then you have the C matrix directly induced with it. Okay. Similarly, if you want to speak of constructibility, where we want to reconstruct the state at t equal to t1. Okay, so let's say that at t equal to t1, the state vector is x1. Then the output at any time t in the interval t0 till t1 with the input of ut can be expressed in terms of x1 as shown here. Okay, now to find x1, we need to solve this equation. This is same as solving for x1 from the equation shown here. This is, you see, this is similar to what we did for observability. Okay, if we solve this equation for x1, then we will be able to find x1. Now again, if it so happens that for a non-zero x1, if y bar comes out to be 0, then essentially the output does not have any information that you can get about what x1 is going to be. Okay, so there is no information of x1, and hence we cannot reconstruct x1 from this particular output. This brings us to the definition of unconstructible subspace. What is unconstructible subspace? Similar to unobservable subspace, unconstructible subspace over the time interval t0 till t1 is defined as all x1 belonging to Rn. So there is a mistake here. It is not x0. This is x1 belonging to Rn. All x1 belonging to Rn such that t phi x1 is equal to 0 for all t in the time interval t0 till t1. Okay. So the x0s here in this set expression have to be replaced by x1. This is a mistake here. I will correct this. Right. So all x1 belonging to Rn such that c phi x1 is equal to 0 for all t in the time interval t0 till t1. So that means that we will not be able to reconstruct x1 from the output. Okay, because output has no information about x1, and hence those x1 will form the unconstructible subspace. Now, if the unconstructible subspace is such that the 0 element is the only element in this particular subspace, then the system is said to be constructible over the time interval t0 till t1. Okay, and again, if you notice, the matrices B and D have no role to play in determining whether a system is constructible or not over a given time interval. It is only the matrices A and C which are responsible for the constructibility of the system. In the next lecture, we'll discuss about the gramians corresponding to observability and constructibility, and we'll see what the conditions on the gramians for which the system will be observable and constructible respectively. We'll stop here. Thank you.